Students, welcome back to All Force Maths class. Dear students, in this session I am going to discuss about family of concurrent lines and family of parallel lines. Okay, please note this value. Family of concurrent lines. The statement: let L1 a1x plus b1y plus c1 is equal to 0, L2 a2x plus b2y plus c2 is equal to 0 are two intersecting lines. L1 and L2 are two intersecting lines. First one, if lambda 1 comma lambda 2 not equal to 0 comma 0, then lambda 1 into L1 plus lambda 2 into L2 is equal to 0 represents a straight line passing through the point of intersection of the lines L1 is equal to 0 comma L2 is equal to 0. Passing through the point of intersection of the lines L1 is equal to 0 comma L2 is equal to 0. Second point, the equation of any line passing through the point of intersection of the lines L1 is equal to 0 comma L2 is equal to 0 is of the form lambda 1 into L1 plus lambda 2 into L2 is equal to 0, where lambda 1 comma lambda 2 not equal to 0 comma 0. From the given, please observe the equations. L1 is one of the equation, L2 is another equation, and these two are intersecting lines. Okay. Now, this equation represents any line passing through that point of intersection. Suppose L1 is equal to this line, L2 is equal to this line. These are intersecting at P. Then this equation represents any line passing through this point P. That means how many lines are possible from a given point P? This is one of the line, this is another line, this is line. Infinite number of lines passes through this point B. All of these lines are said to be a family of concurrent lines. And their point of concurrency is nothing but P. That is the point of intersection of the lines L1 is equal to 0 and L2 is equal to 0. Every two lines are intersecting at P. L1, L2. Say this value is L3. L2, L3 intersecting at P. L3, L4 are intersecting at P. By solving any two lines in that family, we get the point of concurrency. Okay, please observe these points. Even L1, L2 are two intersecting lines. Okay, L1, L2 are two intersecting lines. L1 is this value, L2 is this value. Say these are intersecting L1, L2, and Px1 comma y1 be the one of the point of intersection of the two lines. Here, first line is this value. Say this is equation 1, this is equation number 2. Let Px1 comma y1 be the point of intersection of the lines. Then automatically this point satisfies this line. Okay, that means the line passes through this point. Substituting this point in this equation, we get a1 x1 plus b1 y1 plus c1 is equal to 0. It is equation number 3. And substitute this point in equation 2, a2 x1 plus b2 y1 plus c2 is equal to 0. Say this equation is 3. Now we have to prove that lambda 1 into L1 plus lambda 2 into L2 is equal to 0 is a line passing through the point of intersection of these two lines. Okay, please observe this point. That implies, what is the L1? L1 means a1x plus b1y plus c1. Lambda 1 into a1x plus b1y plus c1 plus lambda 2 into a2x plus b2y plus c2. Okay, this is equal to 0. This L1, lambda 1 L1 plus lambda 2 L2 is equal to 0 means this value. Okay, if this line passes through the point Px1 y1, if this line, this is one of the line. How it is a line? Please observe this point. In this case, after by commoning x, by taking x is the common term, x of lambda 1 a1 plus lambda 2 a2. Please observe this value. X lambda 1 a1 into x, lambda 2 a2 into x. Plus next common term is y. By taking y is the common term, it can be reduced into lambda 1 b1 plus lambda 2 b2 plus next lambda 1 c1 plus lambda 2 c2 is equal to 0. Please observe this equation. It is in the form of ax plus by plus c is equal to 0. It is in the form of standard form of the straight line ax plus by plus c is equal to 0. First degree equation x and y. This equation always represents a straight line. If this line passes through x1 y1, then if this line passes through x1 y1, then L1 plus lambda L2 is equal to 0 is the one of the line belongs to this family. Okay, now we verify the value. Okay, substitute the point p x1 y1 in this equation. By substituting the point p x1 y1 in this equation, we get lambda 1 into a1 x1 plus b1 y1 plus c1 plus lambda 2 into a2 x1 plus b2 y1 plus c2. Okay, b2 y1 plus c2 is equal to 0. But from equation 3 and 4, this value is 0, this value is 0. What is the meaning of this? 0 is equal to 0. True. That means this line always passes through the point P. For irrespective values of lambda 1, lambda 2, for any values of lambda 1, lambda 2, this line always passes through this point P. Therefore, lambda 1 into L1 plus lambda 2 into L2 is equal to 0 represents a family of lines passing through the point of intersection of the lines L1 is equal to 0 and L2 is equal to 0. Okay, very important. In this case, lambda 1 comma lambda 2 not equal to 0. Not equal to 0 comma 0. What is the meaning of this value? Lambda 1 is equal to 0, lambda 2 is equal to 0, except this values all the remaining possibilities. That means lambda 1 0, lambda 2 not equal to 0, lambda 1 not equal to 0, lambda 2 not equal to 0, lambda 1 not equal to 0, lambda 2 0. In this case, lambda 1 is, if we write in this way, lambda 1 comma lambda 2 is equal to 0 comma 0. In this case, lambda 1 is equal to 0 and lambda 2 is equal to 0. Except this case, all cases are possible. Here lambda 1, lambda 2 are parameters. Please observe this value. At the same time, suppose this equation can be reduced in this way. Lambda 1 of L1 plus lambda 2 by lambda 1 into L2 is equal to 0. Move this value to RHS, 0 by lambda 1 is equal to 0. That means L1 plus, take this value single parameter lambda, L2 is equal to 0. The equation L1 plus lambda L2 is equal to 0 always represents a family of concurrent lines passing through the points L1 comma L2. Very important. Please note this point. Note point. Let L1 is equal to 0 comma, let L1 is equal to 0 comma, L2 is equal to 0 are two intersecting lines. Then equation of any line passing through the point of intersection of the lines L1 is equal to 0 comma L2 is equal to 0 is in the form of lambda 1 L1 plus lambda 2 L2 is equal to 0, where lambda 1 comma lambda 2 not equal to 0 comma 0, or L1 plus lambda L2 is equal to 0, where lambda belongs to R. In both of the cases, we get family of concurrent lines. All these lines passes through the common point P. Here, for getting the common point P, by solving L1 and L2, we get the point of concurrency. Please note that point also. Here, the point of concurrency is nothing but the point of intersection of the lines L1 is equal to 0 and L2 is equal to 0. L1 is equal to 0 and L2 is equal to 0. Next, please write the note point, note 2. In previous case, note 1. If L1 is equal to 0, L2 is equal to 0 are two intersecting lines, then L1 plus lambda L2 is equal to 0 always represents a family of concurrent lines. That lines always passes through the point of intersection of the lines L1 is equal to 0 and L2 is equal to 0, or lambda 1 L1 plus lambda 2 L2 is equal to 0. This equation also represents family of concurrent lines passing through that point. Suppose the lines L1 is equal to 0, L2 is equal to 0 are two parallel lines, then lambda 1 into L1 plus lambda 2 into L2 is equal to 0, or L1 plus lambda L2 is equal to 0 represents a family of parallel lines, not concurrent lines. These are parallel. Please observe the equation. Lambda 1 into L1 plus lambda 2 into L2 is equal to 0. It is the family of the lines. First line, say L1 is equal to A1x plus B1y. L1 is equal to A1x plus B1, sorry, parallel lines. Parallel lines means they take AX plus BY plus C1 is equal to 0. Next, L2B, AX plus BY plus C2 is equal to 0. Since the two lines are parallel, The parallel lines means ax plus by plus c1, ax plus by plus c2. What is the slope of this value? m1 is equal to minus a by b, m2 is equal to minus a by b. Slopes are equal. So these two are parallel. Okay. Now lambda 1 into L1 plus lambda 2 into L2. Now we verify this line. Lambda 1 into L1 means ax plus by plus c1 plus lambda 2 into ax plus by plus c2 is equal 0. Here x is the common term, a lambda 1 plus a lambda 2. Next common y, b lambda 1 plus b lambda 2 plus c1 lambda 1 plus c2 lambda 2 is equal 0. Please observe this value. It is in the form of ax plus by plus c is equal 0 for different values of lambda 1 and lambda 2. Okay. What is the slope of this line? Slope m is equal to minus of x quotient by y quotient. What is the common term here? Minus a of lambda 1 plus lambda 2 by b of lambda 1 plus lambda 2. Okay. These two are cancelled, minus a by b. This line is always parallel to the given lines. That means this lambda 1 into L1 plus lambda 2 into L2 is equal to 0 represents a family of parallel lines which are parallel to L1 is equal to 0 and L2 is equal to 0. Okay, very very important. Please note this point. L1 is equal to 0. Let L1 is equal to 0, comma L2 is equal to 0 are two parallel lines. Then the equation lambda 1 into L1 plus lambda 2 into L2 is equal to 0 where lambda 1 comma lambda 2 not equal to 0 comma 0 or L1 plus lambda L2 is equal to 0 where lambda belongs to R represents a family of parallel lines. Represents a family of parallel lines. Very very important. Okay. Please note this value. Next, identical lines or coincident lines. Identical lines or coincident lines. What is the meaning of identical lines? Suppose this is one of the line. This is another line. These two are intersecting at particular point. Suppose this is one of the line and this is another line. These two are parallel. These two are different. In this case also they are different. If this line coincides with this value, this line is again on the line, then these two are said to be coincident lines or identical lines. Okay. Please note this value. Identical lines or coincident lines. Identical lines or coincident lines. If the lines a1x plus b1y plus c1 is equal to 0, comma a2x plus b2y plus c2 is equal to 0 are identical, then a1 by a2 is equal to b1 by b2 is equal to c1 by c2. a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Identical means one of the line coincides with other line. Okay. Please observe this value. From the given first equation is a1x plus b1y plus c1 is equal to 0. It can be reduced into intercept form. Suppose it can be reduced into intercept form. a1x plus b1y is equal to minus c1. By dividing with minus c1, we get x by minus c1 by a1 plus y by minus c1 by b1 is equal to 1. It is the equation of the line in intercept form. Similarly, the equation a2x plus b2y plus c2 is equal to 0 can be reduced into x by minus c2 by a2 plus y by minus c2 by b2 is equal to 1. Please observe this value. Suppose this is the first line. Okay, here what is x-intercept? Minus c1 by a1, y-intercept minus c1 by b1. If this first line coincide with second or second line coincide with first line, again the line is in this way. Okay, here x-intercepts are equal and y-intercepts are equal. What is that meaning? Minus c1 by a1 is equal to minus c2 by a2 and minus c1 by b1 is equal to minus c2 by b2. Here minus minus cancel. That means a1 by a2 is equal to c1 by c2. Here b1 by b2 is equal to c1 by c2. From these two values a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Please note this point. Very very important. Please note this value and again write a note point. Note point. If these lines are parallel, what is the condition? Slopes are equal. Slopes means minus a1 by b1 is equal to minus a2 by b2. Enough. If two lines are parallel, this is the condition. C1, C2 may or may not be equal. If this value C1, C2 is equal to C1, C2, C1 by C2, they are coincident lines or identical lines. Not equal C1 by C2, they are only parallel, not coincident. Please note that point. If a1 by a2 is equal to b1 by b2 not equal to c1 by c2, then the two lines are parallel, not coincident. Two lines are parallel, not coincident. If A1 by A2 is equal to B1 by B2 is equal to C1 by C2, then the two lines are coincident. At the same time, please observe this value. L1 is equal to 0, L2 is equal to 0 are two coincident lines. Then lambda 1 into L1 plus lambda 2 into L2 is equal to 0 represents a family of coincident lines. In previous case, L1, L2 are intersecting, lambda 1 into L1 plus lambda 2 into L2 is equal to 0 are family of congruent lines. If L1 is equal to 0, L2 is equal to 0 are parallel, lambda 1 into L1 plus lambda 2 into L2 is equal to 0 represents family of parallel lines. If these two are coincident, then this represents family of coincident lines. Write this value also. Let L1 is equal to 0, L2 is equal to 0 are two coincident lines. Two coincident lines. Then lambda 1 into L1 plus lambda 2 into L2 is equal to 0 or L1 plus lambda L2 is equal to 0 represents a family of coincident lines. Very, very important. Okay, please note this point. Next, the distance of a point to a line measured along a given line. Please note this point. The distance of a point to a line measured along a given line. Please write the statement. The distance of a point Px1 y1 from the line ax plus by plus c is equal to 0 measured along a line making an angle theta with x-axis is mod ax1 plus by1 plus c by a cos theta plus b sin theta. Please observe this point. Suppose P is one of the point x1 y1 and the line ax plus by plus c is equal to 0. What is the distance from P to this line? Distance is nothing but perpendicular distance. That means mod ax1 plus by1 plus c by root over a square plus b square. But in this case, we find the distance of the point to the line measured along a line which makes an angle theta. Suppose this is one of the line. This line makes an angle theta with x-axis. P is the point here. Now we find the distance from P to this line along this line means this value. This is the value. It is not a perpendicular distance. The distance is measured along this line. Please observe this point. Okay. Please note the diagram. This is the line ax plus by plus c is equal to 0. P x1 y1 is one of the point. The perpendicular distance means this is the perpendicular distance. This is direct formula. Mod ax1 plus by1 plus c by root over a square plus b square. But here we find the distance pq. This value. Okay, please note the diagram. The given line is ax plus by plus c is equal to 0 and this line makes an angle theta with x-axis. Okay, say this line cuts the given line ax plus by plus c is equal to 0 at q. So now we find the distance of this value. Say this value is r. That means r is equal to mod ax1 plus b1 plus c by a cos theta plus b sin theta. We have to prove that r is equal to this value. Okay. In alternative method, this is the point, this is the angle of inclination. That means slope m is equal to tan theta. By using slope point form, we get the we find the equation of this line. By solving these two lines, we get q. Find the distance between pq. It is alternative method, but direct formula it is. Okay. Now, please observe this value. Here, say this value is r units. By using the parametric form, the point q is nothing but x is equal to x1 plus r cos theta, y is equal to y1 plus r sin theta. It is the distance r units. It is r units away from this value. Okay, please note this value. Let the line through P meets the line ax plus by plus c is equal to 0 at q. At q. Okay, and PQ is equal to R units. PQ be R units. Then, what is the value of Q? Q is nothing but by using parametric form. X is equal to x1 plus r cos theta, y is equal to y1 plus r sin theta. What is the angle of inclination of this line? This PQ angle of inclination is theta from the given along a line making an angle theta with x-axis. That means this angle of inclination is theta. Okay, that is equal to q is equal to x1 plus r cos theta, y1 plus r sin theta. Okay, now we find the point Q on this line by using the parametric form. But this Q lies on the line ax plus by plus c is equal to 0. But this point lies on the line ax plus by plus c is equal to 0. By substituting that point in this line, we get a of x1 plus r cos theta plus b of y1 plus r sin theta plus c is equal to 0. Okay. Now required values are after distributing property ax1 plus ar cos theta plus by1 plus br sin theta plus c is equal to 0. Here ar cos theta, br sin theta. What is the common term? R. A cos theta plus b sin theta is equal to, move these values to RHS, minus of ax1 plus by1 plus c. Okay, next, what is the value of r? R is equal to minus of ax1 plus by1 plus c by a cos theta plus b sin theta. But r is the distance. This value is always positive quantity, so we take mod value. Therefore, r is equal to mod ax1 plus by1 plus c by a cos theta plus b sin theta. R is nothing but PQ. Therefore, distance from P to Q is equal to ax1 plus by1 plus c by a cos theta plus b sin theta. Very, very, very important. The distance measured along a given line, not a perpendicular distance. Please observe the difference between these two values. Suppose the perpendicular distance from origin to the line is mod c by root over a square plus b square. The perpendicular distance from point to the line is mod ax1 plus b1 plus c by root over a square plus b square. If the distance is measured along this line, then we use this formula. ax1 plus b1 plus c by a cos theta plus b sin theta. Okay, note this point. Next example. Find the equation of the line passing through the point of intersection of the lines x plus y plus 1 is equal to 0, 2x minus y plus 5 is equal to 0, and passing through the point 5 comma minus 2. In this case, the required line passing through point of intersection of these two values. That means by solving 1 and 2, we get the point of intersection. Required line passes through that point and this point. If 2 points are given, what is the equation of the line? Y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. By using that condition, we find the equation of the line. Or alternative method. Suppose the lines L1 is equal to 0, L2 is equal to 0 are intersecting, then equation of any line passing through this point of intersection is said to be family of concurrent lines. The general form is L1 plus lambda L2 is equal to 0. Any line passing through this point of intersections is L1 plus lambda L2 is equal to 0. Here what is the L1? X plus y plus 1 is equal to 0. That means x plus y plus 1 plus lambda into 2x minus y plus 5 is equal to 0. It is the equation of the required circle. Please observe this point. First we find the point of intersection of the lines, and by using this point we find the equation of the line. That is first method. Already we know about that point, that type. Okay, alternative method. L1, L2 are intersecting at the point P. Any line passing through this point is nothing but in L1 plus lambda L2 is equal to 0. By using this condition, we find the equation of the line. But this line passes through which point? 5 comma minus 2. Substitute the point 5 comma minus 2 in this equation, we find the value of lambda. And by substitute this point lambda in this equation, we get the required line equation. Okay, this is method. Please write this value. What are the values of L1? L1 is x plus y plus 1 is equal to 0. L2 is 2x minus y plus 5 is equal to 0. Equation of the line passing through the point of intersection of the lines L1 is equal to 0 and L2 is equal to 0 is L1 plus lambda L2 is equal to 0. That implies it is the equation of the required line. But it passes through 5 comma minus 2. Substitute this point. 5 minus 2 plus 1 plus lambda into 10 plus 2 plus 5 is equal to 0. That means 5 minus 2 means 3 plus 1 4. Okay. Plus lambda into 17 is equal to 0. What is the value of here lambda? Lambda is equal to minus 4 by 17. Substitute the value of lambda in this equation, we get the equation of the required line. That means what is the equation of the required line? X plus y plus 1. Lambda value is minus 4 by 17 into 2x minus y plus 5 is equal to 0. After LCM, it can be reduced and 17 is the LCM. Multiply this value and simplify. It is the equation of the required line. or you use that method. By solving these two values, find the equation by using 2 points form. Okay, next one, example 2. Find the equation of the line passing through the point of intersection of the lines 2x minus 5y plus 1 is equal 0. 2x minus 5y plus 1 is equal 0. Second line, x minus 3y minus 4 is equal 0. And making equal intercepts on the coordinate axis. Please observe these values. This is the first equation, this is the second equation. Required line passes through point of intersection of these two values. By solving 1 and 2, we get the point of intersection. First method. By solving 1 and 2, we get the equation of the point of intersection of the two lines x1, y1. Okay, but the required line makes equal intercepts on the coordinate axis. If the line makes equal intercepts on the coordinate axis and passing through x1, y1, what is the equation of the line? X plus y is equal to x1 plus y1. By using this formula, we find the equation of the line. It is the first method. Already we know about this value. By solving 1 and 2, we get point of intersection. Okay, next, if the line makes equal intercepts, what is the equation? X plus y is equal to x1 plus y1. By using this formula, we find the equation. Second method. The equation of any line passing through point of intersection of the lines L1, L2 is equal 0. L1 is equal 0, L2 is equal 0. That value is nothing but L1 plus lambda L2 is equal 0. The equation of the line passing through point of intersection of these two lines is in the form of L1 plus lambda L2 is equal 0. That means 2x minus 5y plus 1 plus lambda into x minus 3y minus 4 is equal 0. It is the equation of the required line. But lambda is unknown value. We find the value of lambda. Why? How we find the value of lambda? Here, what is the condition? The line making equal intercepts on the coordinate axis. If the line ax plus by plus c is equal 0 makes equal intercepts on the coordinate axis, what is the condition? X coefficient is equal to y coefficient. What is the condition? X coefficient is equal to y coefficient. By using that condition, we find the value of lambda. Okay, here the line, since the line makes equal intercepts on the coordinate axis, therefore x coefficient is equal to y coefficient. X coefficient is equal to y coefficient. What is the x coefficient? X coefficient is equal to y coefficient. Here x coefficient is 2x plus lambda x. What is after common x? 2 plus lambda. That value is 2 plus lambda. Please observe this value. 2x plus lambda x means x of 2 plus lambda. X coefficient is 2 plus lambda. What is the y coefficient? Minus 5y minus 3 lambda. After common y, minus 5 minus 3 lambda. Minus 5 minus 3 lambda. Please observe this value once again. X coefficient is 2 plus lambda. Y coefficient is minus 5 minus 3 lambda. Okay. After simplification, 4 lambda is equal to minus 5 minus 2 means minus 7. Lambda is equal to minus 7 by 4. Substitute the value of lambda is equal to minus 7 by 4 in this equation. We get the equation of the required line. Okay, substitute this point in this equation. That means required line is 2x minus 5y plus 1 minus 7 by 4 into x minus 3y minus 4 is equal to 0. After LCM, it can be reduced into 8x, okay, minus 20y plus 4 minus 7x minus 21y minus 28 is equal to 0. Simplify this value. What is the equation of the line? Find this value. Next, find the point of concurrence of the family of lines 2 plus 5k into x minus 3 of 1 plus 2k into y plus 2 minus k is equal to 0, where k is parameter. For different values of k, we get different lines. All of these are family of concurrent lines. What is the point of concurrency? What is the given equation? 2 plus 5k into x minus 3 of 1 plus 2k into y plus 2 minus k. Split this value. After distributing property, 2x plus 5kx minus 3y minus 6ky plus 2 minus k is equal to 0. You separate k terms and non-k terms. Contains k and does not contains k. So 2x minus 3y plus 2 plus k of 5x minus 6y plus 1 is equal to 0. Please observe this value. It is in the form of L1 plus KL2 is equal to 0. L1 plus lambda L2 is equal to 0 is nothing but family of concurrent lines. family of concurrent lines. What is the point of concurrency? By solving L1 is equal to 0 and L2 is equal to 0, we get the point of intersection. Here L1 is 2x minus 3y plus 2 is equal to 0. L2 is 5x minus 6y minus 1 is equal to 0. Find the point of intersection of these two lines. Then we get the point of concurrency. Okay, please note this point. Please write this value.